Welcome to the Earth Science Classroom. This video is all about sequencing and the teaching methods and the sequencing that I employ and put into my classroom, my students. We're going to look at a certain part of the curriculum. This video is going to focus on a certain part of the year, which includes certain topics which start at petrology and minerals, and how I build through each topic, how I connect and how I flow into each part of the curriculum to build upon itself and build the foundation of knowledge. Hopefully this understanding of the Earth as a system, especially geologically, and I can branch off to different areas of geomorphology and geology and other areas, and to build the students' knowledge in this part of the curriculum. So what we have here is a flowchart or a sequence example from a part of the curriculum. I would start this around October to November of the academic year. Now in the northeast of America, we start our school year after Labor Day generally, and we go through until the middle of June or the end of June. This would be kind of like there's 40 weeks in a school year. This would be around 12 to 15 weeks worth of material. And in terms of how many lessons you have in a week and how long the lessons are, that can obviously change and fluctuate. But the proportion or a section of the curriculum is devoted to this part of instruction and topics. So I would start over here in the left-hand top corner and look at minerals, and to start to build the students' knowledge of geology, and from there that foundational knowledge to build upon middle school science and take it into that more rigorous and connected high school science with a higher level of scientific detail and analysis. We're going to start with minerals, mineralogy, crystallography, looking at different structures of crystals, and so looking at some basic chemistry, looking at elements, looking at atoms, looking at how they combine and how they bond with ionic and covalent bonding. We're looking at how these turn into molecules and compounds and how they form into different elements, looking at the periodic table, looking at the main elements in the Earth's crust and the 8 main elements, and then flowing into how these minerals combine to form rock. And the basis of rocks, the 3 types, is minerals, and how the different minerals combine to form different kinds of rocks. You can also bring in the rock cycle. So I would start with minerals, go into the 3 types of rocks, explain them examples, and look at the rock cycle and how this continuous long-term cycle of material happens both under the crust, in the Earth's interior, different Earth's layers, and discuss on the surface, and weather and erosion. So weathering and erosion is by itself is a massive topic, and mass movement and mass wasting, and how the surface with the heat from the sun and weather and climate, in addition to the heat from the interior of the Earth, from the mantle and the core, and how these relate to the surface processes. So how the landscape and the Earth's crust are formed and change over time, and this would lead into the topic of geomorphology in different landscapes. So even look into different kind of terrains and look into the formations of these terrains and landscapes and topography. The rock cycle and the knowledge of minerals and rocks leads into this topic of geomorphology, and can also lead into basics of geophysics and the discussion of the Earth's interior layers, and the chemical layers and physical layers, and the heat generation and the convection currents in the asthenosphere and the transition zones and the MOHO and different boundaries, and all this stuff plays into the understanding of how the Earth functions as a rock of different densities, composition, and temperatures. And this can lead into convection currents in the asthenosphere, which lead us into our lovely plate tectonics. We can also link in continental drift and Wegener in 1912 and 1915, and also looking at Hess and other different scientists. We're looking at seafloor spreading and the ridge and paleomagnetism, and the generation of our 1960s all-encompassing theory of plate tectonics. And that leads us into both seismology and volcanology, and the addition of where in plate tectonics where we generate magma, how we generate magma. So again, back to our geophysics and our geochemistry, how to produce liquid molten rock from solid rock, and the different areas, and how this leads into volcanology, and how this leads into the friction and energy and seismic and elastic energy being produced, which is the large topic of earthquakes. Now, going back to the Earth's interior and also the rock cycle, especially with sedimentary rocks, we can look at the principles of geology and the rules in which we base our knowledge of geology and the Earth's history and the age of the Earth and different time periods and eons and eras. And we can look at geologic history and obviously look at Hutton and Steno and other amazing scientists that paved the way for modern day geology and our understanding of how the Earth functions over time and recycles materials over a long time scale. With this, you can branch off to any different discipline or topic or subject and have different case studies, examples, demonstrations, labs, different kind of assessments, different kind of field trips, and you can really build your knowledge from minerals, petrology, which is rocks, the rock cycle, and the Earth's interior. These four key components or key topics really allow you as the teacher and the student to divulge and branch off into other areas of geology and geomorphology, which, and also natural hazards and disasters. We can really build on this knowledge because we understand how minerals, rocks, and the rock cycle and the Earth's interior all interact to create this dynamic, connected system that is our planet. This is the Earth Science Classroom. Thank you for watching. I hope you enjoyed the content. Check out more videos on our channel. And don't forget to subscribe. Thank you again.